I want to show you this before I erase it. I did this whole video for you on point slope form, and I realized when I got to the end that I lost my negative sign right here. That's a negative. It will be a -3. So you know what I'm going to have to do? You do. Because I lost the negative sign, I'm starting over. Mistakes happen to us all. That's okay. But I should know better than that. And I'm putting my glasses on now. All right, let's try this again. Or I'm going to try it again. You're just seeing it the first time. So we're looking at point slope form. And this is just another form of an equation. You've learned standard. You've learned slope intercept. So this is one more form of an equation. Now don't panic on me. This one looks pretty bad, but I promise you it's okay. In algebra, things look really horrible until you understand them, and then they're not so horrible. At least I don't think so. Some people still say they are, but there's the basic pattern of point slope form. So if my professor tells me to put an equation in point slope form, this is the pattern she's wanting me to use. Now, before we go any further, I want to call your attention to something. Namely, this fella and this one. This one and this one, look at the difference there. Let that difference sink into your mind. The ones with the subscripts are the ones that will be replaced by numbers. This one and this one are still going to be in my final problem when I'm done. So those two are not getting replaced. You want to look for the ones with subscripts to be replaced. So keep that tucked away. So here's the pattern of point slope form. And if you're following me in a textbook, I'm on page 159. I'm at example 4. But for those folks who don't have a book, let's go ahead and write this out. A line has slope 1 and contains the point 4 negative, Amanda, it's a -3. That's where I messed up the first time. I lost that negative sign and it ruined the whole thing. Write the equation of the line in point slope form. And I'm going to put form right there because I have a reason for that. Okay, I've had two things happen here. I've had students absolutely melt down. They see this pattern and they see this problem and they're just, I can't do this. I have no idea what they're talking about, and they just go all to pieces. The other thing that happens is I see students say, oh, I know how to do this. I need to find baby B. I need to find that value, and then I can do what I did in the problem before. And that's great thinking, except for one thing. Baby B is not at this ball game. There's nothing in that pattern that talks about baby B. Up here, there was. That pattern asks for baby B. But this pattern does not. So baby B is not the route that you want to take on this one because it's not in the pattern. That's why it's so important to know your patterns. So let's look at what we do know. We know what we need to do this. You can do this. You know slope. You know a point, so you know an X and a Y. And you know the pattern they're looking for. You've got it right here. We know that slope is 1. We know that X is 4. Y is negative 3. And you may be thinking, how do you know that? Where does it say X and Y? Right there. Anytime you have a coordinate, you have an X first and then a Y. So that becomes these values. And the most important piece of this puzzle is you know the pattern they're looking for. So let me write it again. We have Y minus Y1 equals M times X minus X1. Those parentheses are telling me that I will have to multiply. Now remember what I told you just a minute ago about this term and this term. Those will be replaced by numbers. This Y needs to stay in there. This X needs to stay in there. So I'm going to look right here for Y, that's negative 3, and I'm going to put that in parentheses. It doesn't mean to multiply, I just don't want to get confused with those two negatives and lose one of them. Then the X over here is 4. X sub 1 is 4, and you know slope is 1. Okay, we just need to simplify a little bit. We've got to multiply that 1 to get rid of the parentheses. So you have Y minus negative 3 over here. 1 times X is 1X, and 1 times negative 4 is negative 4. I know that when I have two negatives like that side by side, it's going to make a positive 3 in this case. And I know that an algebra book will not include that coefficient of 1. In other words, I used to tell my students, this is a ghost one. You may see it or you may not. It can be there, it may not be. It floats in, it floats away, and the value of your problem does not change. This is the answer. You do not want to move anything around because they want it to be in point slope form. So that is all that you need to do. You will not use this a lot. Let me go ahead and take this a step further. I know I'm pushing the envelope just a little bit, but hopefully you're with me and you understand what I'm doing. Let's go ahead and write this equation that we just got. Remember, this is called point slope form. Let's go ahead and write that equation in slope-intercept form. Now we need the pattern for slope-intercept form, and that is y equals mx plus b. Okay. So let's draw our t-chart if you want to use the t-chart. And on this side, we're supposed to have just y's. On this side, whoops, I'm getting ahead of myself. Let's go ahead and put the one we want to change right in here. Remember, we know our slope is 1. It may be there, it may not. It's up to you. I like it there, but it's up to you. But now this needs to be worked. We need to do a little work here. I want y over here, so that can stay there, but that 3 has to go. I've got slope where it needs to be. I've got an x where it needs to be. And I've almost got baby b, but I need to deal with that 3. So let's move the 3 by the opposite. And so y equals mx plus b. You could say plus -7, or you can just say -7. And that's the same equation in slope-intercept form. Okay? All we're doing, we have the same quantity. It's just putting on a different outfit. It's just changing clothes. Here it's wearing its slope-intercept outfit. Here it's wearing its point slope outfit. Do I dare? I'm going to. What if we want it to put on its standard outfit? So what if we want to take this same formula that keeps changing clothes and write it in standard form? Could we do it? Sure we can. If we know the pattern, we can do it. So I'm going to go all the way back to the top and get the pattern for standard form. Right there. I bet you I just messed up, but let's see. Nope, let's just write it again. Remember, the pattern for standard form is big A, little x, plus big B, not baby B, y, equals a constant. Okay, that's the pattern. So I want to make sure that my equation looks like that pattern. So let's bring it over here. We've got, I tell you what, let me do it this way. Don't erase. I didn't mess up. I just need a little more room. Let's put the pattern on the top. So whatever you want it to look like, put that on the top of the T. So our equation, that's going to be this one, is going to come right up here. Y equals 1x minus 7. So we have y, there's the equals, 1x minus 7. Okay, let's figure out what can stay and what needs to go. So the y is in the right place, and you say, well, I don't know big B. Yeah, you do. Remember, that ghost can float in or out. So the y is in good shape. Even the plus sign is in good shape. C, constant, is a -7. That one can stay where it is, but you can see the problem. There's the x and there's the x. That one's got to come over here. And you do that with subtraction. And this cancels. And there you've got it. It's the same quantity. It's the same function. It's just wearing different clothes this time. This time it's got its x's and y's on one side and its constants on the other. That is standard form. And on a test, you will see it like this. They will leave the ghost zeros out on a test. Okay. So all of that is related. It's very closely related. It's just a matter of changing the outfit. If you want it in standard, in slope-intercept, or in point-slope, you just have to manipulate the formula till you have what you're looking for. Okay, I think I am going to do a few more practice problems on this I'm not going to in this video, but we will do a few more problems too. Actually, there are some on page 160 that we can do. So I'm going to stop this video and I'll come back and do a few more examples of these problems.